So this video is going to be slightly different than videos we've done in the past. This video is strictly going to be on Excel, and the topic is quadratic forms, as you can see at the bottom right of the spreadsheet. Quadratic forms is where a square matrix, like a covariance matrix C, is pre-multiplied by a conformable vector, or weights, and post-multiplied by that same vector to get a scalar. Now suppose we have a 6 by 3 data matrix with 6 persons each being measured on 3 variables. So I'm going to enter that into matrix A, which is up here on the top left. And I'm going to enter the values going down 8, 6, 5, 5, 4, 2, and then 12, 16, 10, 8, 10, 4. And then in the last column, 10, 9, 11, 11, 6, and 4. Once again, let's just say these are 6 people, and they're measured on 3 variables. So let's first get the sums of the columns here. What you can do is hit equal, and then sum, highlight the column, close your parenthesis, we get 30. We can drag that out to give us the sums of each column there. And let's also get the mean. So you can hit equals and then type average, open parenthesis. We're going to average this first column, close the parenthesis. And you don't need to hit Control-Shift return, just hit enter. Bring that over and we have our averages. I'm actually going to copy and paste this A over here as well. So now, looking over here to the left side, suppose that we want to post-multiply matrix A by a 3 by 1 vector of 1s, which we will call W. And we can say these are weights. This has the effect of creating a new vector, TW, T sub W, that is a 6 by 1 vector of the sums of the 3 variables for each of the 6 persons. So we're going to highlight this 6 by 1 matrix equals, we're going to do matrix multiplication and highlight A, comma, W. We're going to post multiply by W, Control, Shift, Enter. And now we have a new vector I labeled, you see here, T sub W. That's a 6 by 1 vector of the sums of the 3 variables for each of the 6 persons. So you can add these rows and you'll get this to be the sum because we multiplied by a 3 by 1 vector of just 1s. And this we'll say is a linear combination, as you see here. Now let's just get the sum of this 6 by 1 vector and the mean as well. So we're just going to equal sum, highlight it, enter, equals average, highlight it, close the parenthesis, enter. And also here, as you see highlighted in yellow, I want to get the variance of this. So we're going to do equals VAR for variance, open parenthesis, highlight the matrix, close the parenthesis, and hit enter, and we get 59.9, which is pretty much 60 there. So next what we want to do is get the covariance matrix. We can get that by getting the SSCP, the sum of squares and cross products matrix, and subtract that by Tm, which is the T is the total, the column sums here, and the M being the means of the columns, which we've calculated up here. And that will give us the centered sum of the squares in cross products matrix, which we can use to find the covariance matrix. So let's first find the SSCP. So you can get that by hitting equals, it's going to be matrix multiplication, so MMULT, open parenthesis, and what we need to do is actually take the transpose of A, and we're going to multiply that by A. So I'm going to do this all in one step. I'm going to do transpose, open parenthesis, highlight A, so essentially it's going to create the transpose of A, close your parenthesis, and then comma, finish the matrix multiplication. We're pre-multiplying transpose of A times A, so we're going to highlight A again, close the parenthesis, and Control-Shift, return. And you should do that for the whole matrix. Okay, and for the next step, we need to find our Tm matrix here. So this is also going to be matrix multiplication. And we're also going to need transpose. Remember, T is the total, it stands for total, it's the column sums of our matrix A. But we need to take the transpose of that. So we're going to do transpose of our sums here. Just like what we did with the SSCP, we're going to close a parenthesis, comma, and then M is the means. So we're going to take the means here, close the parenthesis, Control-Shift, return. So the reason why you need to take the transpose of T, because if you notice here, these are both 1 by 3 matrices, and you cannot multiply a 1 by 3 matrix by a 1 by 3 matrix. It's not conformable that way. So we're going to have to take the transpose to make this a 3 by 1 matrix. And when you make it a 3 by 1 and you multiply that by a 1 by 3, what do you get? You get a 3 by 3 matrix, which we have here. Alright, the next step is finding the centered sum of squares and cross products. So what we're going to do is we found out from video 3.18 when we talked about different calculations of the CSSCP. And this is using equation 3.2 in the text. What you can do, we can highlight this, and this is going to be equal to our SSCP minus our Tm matrices. And I'm just going to put these in parentheses. There you go. You get the values going across 20, 30, 21, 30, 80, 28, 21, 28, 42. So the last step in finding our matrix C, the covariance matrix, is to take the CSSCP matrix and divide by n minus 1. What is n again? Yeah, n is the number of subjects we have, which is 6, so n minus 1 is 5. So what we want to do is make this equal to our CSSCP matrix divided by 5. And we get those values: 4, 6, 4.2, 6, 16, 5.6, 4.2, 5.6, 8.3. So now we have a 3 by 3 covariance matrix C that was obtained from this 6 by 3 data matrix A with 6 persons, each being measured on 3 variables. As I showed up here, we did find the variance using this linear combination, multiplying A times this W of weights of 1s to find this linear combination. And we ended up getting the variance of that. We can also obtain the variance of that simple linear combination vector T by pre-multiplying and post-multiplying the covariance matrix C by that same 3 by 1 vector of 1s. So let's do that here. We're going to pre-multiply, so it's 1, 1, 1, and post-multiply 1, 1, 1. And so in this yellow box, let's do matrix multiplication. So MULT. Since we're doing matrix multiplication twice, I'm going to write that twice, or type that. So our first one is going to be this W transpose, comma, covariance matrix. So we just did one matrix multiplication. Now we're finishing up the other, comma, and you're going to highlight our last matrix there, the vector of 1s. Close your parenthesis, Control Shift Enter, and in fact we do get 59.9, which is the same value obtained by directly calculating the variance of vector t that we did up here in cell L10. Now, suppose that we wish to obtain a different linear combination of the matrix A. We wish to use the weights 1, 3, and -2, which I'm typing as vector v. And we find that this linear combination, vector t sub v, which I have here in cell v5, has a variance of 133. So let's do that here. Matrix multiplication, we're going to do A, comma v, let's take the sum of that, and let's take the average or mean of that, which we get 108 as the sum and 18 as the mean. And we can also find the variance, VAR, let's highlight T sub V, and the variance does come out to be 133. Now, as we just talked about, we can use the quadratic forms method to calculate the variance of the linear combination, and we confirm that it does match the one directly calculated. So let's do that down here. I'm going to enter our V as 1, 3, and -2. 1, 3, and -2 here. Once again, this covariance matrix is equal to the centered sums of squares and cross products divided by 5. And let's find the variance here. So matrix multiplication, highlight the first matrix and second matrix. Okay, so that completes one. I'm going to go back to the beginning and add matrix multiplication, comma. Now let's do this last one. And in fact, we do get 133. Now, as you see here, I have one space left that is yet to be filled. It's covariance. We're actually going to talk about that in the next video on bilinear forms. I just want to build up the anticipation. You're probably so excited to know what the covariance between these are, but we'll talk about that in the next video. So that was a video on quadratic forms. And just as a side note, we did use quadratic forms near the end of chapter 2, and we will also use it more in chapter 4. So it is very important to know. Hope you have a good day. See you in the next video.